See, Standard 10th Maths, Chapter 6, Trigonometry, Exercise 6.3. An aeroplane at an altitude of 1800 meter finds that the two boats are sailing towards it in the same direction. The angles of depression of the two boats as observed from the aeroplane are 60° and 30° respectively. Find the distance between the two boats. See, this is sum number 4 in exercise 6.3. An aeroplane at an altitude of 1800 meter from the ground. See, let me take the position of this aeroplane. A, B. From the ground, the aeroplane is 1800 meter height. The two boats are sailing in the same direction. Let me take the position of the boats as C and D. They are on the same line. So this is 90°. So from the aeroplane, I observed the two boats whose angle of depression is 60° and 30°. So from the aeroplane, this is the position of the aeroplane. Normal sight is this. So I have to see the two boats. So the depression is here. You are getting here one angle. And I am looking the boat far from this D, position D. Here one angle of depression. The two angle of depression is given as 60 and 30. So the greater angle is 60 and the smaller one is 30. So 60 is making with the line AC. So alternate angles are equal. This is line of sight and this is the horizontal line. So the two lines are parallel. So alternate angles are equal, 60°. And this angle you are getting here 30°. Question, find the angle between the two boats. That's all. So let me take that AB, height of the aeroplane. Height of the aeroplane from the ground. So AB is equal to 1800 meter. C and D are two boats. So I have to find the distance between the two boats. So here we are getting two right angle triangle. Here angle B is 90° common for both the triangles. One is triangle ABC. One angle is here 60. The other triangle is ABD. Here one angle is 30. So mark the two triangles, triangle ABC and the other one is triangle ABD. In both the triangles, angle 60 here is C is 60 and here angle D is 60. So on both the side you write the remaining letter AB and the remaining letter here is again AB. Take tan 60. Tan 60 here, sorry, this is 30. Tan 30. Tan 60 is opposite side by adjacent, AB by BC. Tan 30, again this is opposite side, AB by BD. So AB by BC, AB by BD. Tan 60 is √3. What is AB? Height of the aeroplane from the ground, 1800. BC we don't know. Tan 30 is 1 by √3. Again AB is 1800 divided by BD. So you take this BC to the left side So 1800, bring this root 3, it comes in the denominator. Here cross multiply, BD is equal to 1800 root 3 into root 3. See, you rationalize the denominator here, 1800 by root 3 into root 3 by root 3. I have to remove this root 3. So root 3 into root 3 denominator is 3, 1800 root 3. So 3 goes here in 1800, 6 3s are 18, 0, 0, 600 root 3. So this you keep as it is. So you are getting BC. BC here is 600 root 3. From BD here 1800 root 3. I need to find what is CD. The distance CD. So this BD is equal to BC plus CD in the diagram. BC plus CD. BC plus CD. So what is BC? BC is equal to 600 root 3 plus CD. You have to find BD is 1800 root 3. So both the values you have got here. So CD, keep CD here. 1800 root 3 minus 600 root 3. So 1200 root 3 is equal to CD. So what is the value given for root 3? 1200 into root 3 value is 1.732 is equal to CD. You multiply these two numbers, keep the decimal, after 3 decimals you will get here. See, actually you can multiply in this way also, add 2 0 here. 12, remaining 12 you have 12 2s are 24, 2 carry over, 12 3s are 36, 38, 3 carry over, 12 7s are 84, 87, 8, then 1 12s are 12, 20. So after 3 decimals I keep the point here. So 2078.400 CD. What is CD? The distance between two boats. The distance between the two boats. Two boats is equal to 2078.4 meter. This is the answer. See the fifth sum. From the top of a lighthouse, the angle of depression of two ships on the opposite sides of it are observed to be 30 and 60 degree. If the height of the lighthouse is h meters and the line joining the ships passes through the foot of the lighthouse, show that the distance between the two ships is 4h by root 3. See here, two ships you have, the lighthouse. From the top of the lighthouse. Actually, the lighthouse we see on the seashore of the seashore. Here, lighthouse AB, whose height is given as h meter. H meter. See the two ships we observe on either side of the lighthouse. C and D are position of two ships on either side of the lighthouse. So the ships and the foot of the lighthouse are on the same straight line here. Given. The person is standing on the top of the lighthouse. So his normal side is this. And he is looking the position of two ships, ship C and ship D. See here, both the case you are getting the angle of depression. One is 30 and the other one is 60. 30 and 60. Question, find the distance between the two ships. So AB lighthouse. So AB height is given as here for you h meter. See here the normal side, here this is a line of sight. So alternate angles are equal. Here you will get 130 and here you are getting alternate angles are equal 60 degree. C and D are two ships. So you have to find what is CD, distance between C and D. I consider the two triangles, both are right angle triangle. Right angle is at B. So one is triangle ABC, the other one is triangle ABD. Triangle ABC, triangle ABD. So 30. Angle C is equal to here 30. Angle D is equal to 60 here. So on either side you are getting here ACB and here ADB. So take tan 30. This is tan 60. Tan 30 is opposite side by adjacent side, AB by BC. Tan 60 again opposite side, AB by BD. So what is tan 30 value? 1 by root 3. AB is h by BC. Tan 60 root 3, AB is h by BD. Cross multiply. BC is equal to root 3h. Here cross multiply BD. Bring down this root 3 to the denominator on the other side, h by root 3. You are supposed to find CD. What is CD? CD is BC plus BD. CD. BC plus CD. BC plus BD. BC is root 3h plus h by root 3. Take root 3 as LCM. So here denominator term is 1. Just multiply root 3 into root 3, 3h. Root 3 it goes one time, so it's just you are getting h. So 4h by root 3. 4h by root 3. So this is what you have to prove. CD, distance between two ships. Distance between two ships is equal to 4h by root 3 meter. See, 6th sum. A lift in a building of height 90 feet with transparent glass walls is descending from the top of the building. At the top of the building, the angle of depression of a fountain in the garden is 60 degree. 2 minutes later, the angle of depression reduces to 30 degree. If the fountain is 30 root 3 feet from the entrance of the lift, find the speed of the lift which is descending. See here, you have the building AB. So let me take the position of the lift as A. The lift is on the top of the building. The building height is 90 feet. 90 feet it is given. So from the top of the lift, in the position of the lift, the normal side is this. This person is looking at the fountain on the ground. So his angle of depression is here mentioned as 30 degree. Not 30. Here the angle of depression of the fountain in the garden is 60 degree. 60. here 60. So here you join the foot of the building and the fountain. So here these two lines are parallel. This is line of sight and this is the horizontal line, ground. So alternate angles are equal. So you are getting 60. So after 2 minutes, see, as the lift getting down, after 2 minutes it takes the position D. Let me mark it as D. 2 minutes. They don't give the distance. They mention the time. After 2 minutes, the lift comes down at the position D. So its normal sight is here. Now from here they are looking at the fountain. So now the angle of depression is 30 degree. So this is 30 degree. 30. Question is, find the speed of the lift. First you have to find the distance. So time we know, after 2 minutes how much of distance it covered here, AD. Then if I can find the speed. So for this, let me take here AB, building, AB is equal to 90 feet. 90 feet. And A is the position of a lift. A is the position of the lift. Position of the lift on the top of the building. And C is the position of the fountain. C is the position of the fountain. And also one more measurements. Just look at here. If the fountain is 30√3 feet from the entrance of the lift. See the fountain, the distance between here, the entrance of the lift and the fountain is 30√3 feet. This is very important. So 30 BC is equal to 30√3 feet. See one more point here. The distance covered in 2 minutes is AD. The distance covered in 2 minutes. The distance covered in 2 minutes is AD. So you have to find what is AD. If you find AD, here the question, find the speed of the lift. So the time here taken to cover the distance AD we know, and you have to find the distance, what is AD. So for this we have again two triangles, one is with the 60 degree, one is with 30 degree. When I take the bigger triangle 60, I know both the sides AB by BC. I don't know both the sides are given here, AB 90 feet and BC 30√3. So don't take this bigger triangle. You take the smaller triangle, that is triangle making an angle with 30 degree. So here triangle DBC, DB is 90 here. Let me take the triangle DBC alone. So in DBC, angle C is here 30. So DB. Take tan 30. So tan 30 is equal to opposite side by adjacent, DB by BC. DB by BC. What is tan 30? 1 by √3. DB we don't know, we have to find. And also BC is 30√3. 30√3. So cross multiply 30√3 by √3. Keep this √3 as it is equal to DB. √3 cancel. So DB is equal to 30. So DB is equal to 30. Up to this 30. As I said, 30 feet. As I said, I have to find what is AD. AD. So how do you get AD? AD is on the line segment AB. So AD plus DB is equal to AB. AB is equal to AD plus DB. But we know AB is 90 feet. AD I am supposed to find. DB just now I have got 30 feet. This is 30. So AD is equal to 90 minus 30, that is 60 feet. AD is equal to 60 feet. So we are supposed to find the distance. Speed. Speed is equal to distance, formula, distance y time taken to cover that distance. So distance AD is 60 feet divided by time taken is 2 minutes to cover this distance. That is 30. 30 feet is in the numerator, denominator minutes. So speed is equal to 30 feet per minute. For 1 minute, 30 feet. So this is the answer. So here, very easy question. Just you have to find only single triangle. Because for the 60-degree bigger triangle, we know both the sides. Both the sides are known one, no unknown sides. So in that case, you take 30 and proceed this problem. Very easy one. Thank you.